Okay, in this video we're going to be talking about the sine ratio for the trigonometry. I'm going to have a little entry information and then a sheet for notes, as well as some guided problems at the end. So let's go ahead and look at sine and for trig. And when most people hear trig, again, they go, oh my goodness, but it really is just a matter of formulas with proportions. And sine, just like Pythagorean theorem or the distance formula or slope-intercept form, it's just a name to describe a certain formula or ratio, which is just one thing divided by another. So this is the foundation that we want to look at for understanding not only sine but trig in general, which is if I have a right triangle and an unknown angle, or technically even a known angle, but usually unknown angles are represented with theta. The hypotenuse is always the side length that is across from our 90-degree angle. Adjacent is the side length between the 90-degree angle and whatever angle we happen to be working with, whether it's a known or an unknown angle. So in this situation, since it's this angle, then this is the adjacent. It's the side next to it. Right? The opposite is, well, the side across from the angle that we're working with, either the known or the unknown angle that we're working with. Since we're working with angle A in this theta, the one across from it is our opposite. Okay? And so when we talk about ratio, just remember ratio is just a division of two numbers. And those numbers are going to either be this length, that length, or possibly, depending on the situation, be working with our angle itself. So ratio is an amount divided by another amount to give either a fraction. 2 divided by 3 is a ratio, or the decimal. 0.25 might be an example too. So when it comes to sine and its ratio, its formula is going to be based on the length of the opposite side divided by, that's all this line means, is divided by the hypotenuse. It is literally a division problem. That is the bulk of this. So you're going to use sine when you're dealing with measurements of an angle and the side opposite of the angle and the hypotenuse of the right triangle. So if you have those 3 bits of information, so in other words, we're completely ignoring the adjacent altogether. If we only have these 3 bits of information, then technically we can use the sine formula. And that, again, is going to be the opposite, whatever that measure is, divided by the hypotenuse, is equal to the sine of theta, which we use our calculator for to figure that one out. Okay. So if you're given, and again, this is just a quick overview, and then also show you some more detailed notes that you can actually use. So just kind of a quick example of this concept. It says if I have something that looks like this, and if you notice I have an opposite of theta, and I have a hypotenuse, okay? So you always want to say, based on what information you have and what information you're looking for, which trig ratio you're going to use. In this situation, I'm actively trying to use the sine. Once you figure out what information is given, thus which trig formula you're going to use, you then say, okay, well, my angle is how much? My opposite is how much? My hypotenuse is how much? And or, if needed, my adjacent is how much? And then plug those into your ratio and solve, just like it was a proportion. Remember, proportions could be 2/3 equals x over 6. Solve for x. That's all a proportion is. That's all the trig is. And I'll give you some more examples in just a moment. Okay? So please feel free to pause these. This is more of the notes themselves that you can actually, any of that piece of paper from the previous page, you are also welcome to copy down. But I set this one up to focus more on the sine ratio itself. And again, feel free to pause. So sine says you're going to be dealing with one of these two situations here. You're either going to deal with an angle and its opposite and hypotenuse, or you're going to be dealing with an angle, its opposite, and hypotenuse. So notice that the opposite varies and changes depending on where the theta is and the angle that you're working with. So the sine is going to be the sine of theta, this is again using your calculator, times, entered an angle, equals opposite divided by hypotenuse, division problem. Use the sine if one of these pieces is unknown. So we're going to have three situations. So feel free to divide your paper into three sections from here on down, because I'm going to show you the three different examples depending on whether you have a missing angle, a missing opposite, or a missing hypotenuse, as to how about to use the sine ratio to solve for those. So let's look at situation 1. So let's say you have an unknown angle. Again, please feel free to pause the video. So the first thing I'm going to do is identify my pieces. Number 1, step 1. My angle is unknown, my opposite is 9, my hypotenuse is 15. So remember our formula says the sine of theta is equal to our opposite divided by our hypotenuse. So we're going to use sine and use our formula to be able to plug in our information and solve. So there it is. That is technically our formula. Now to use it, we're actually going to come and use, to solve for theta in this situation, traditionally you divide by sine, but it's the inverse, which is on your calculators, sine to the -1. So if you actually come to your calculators and do second sine, you'll see that it actually has sine to the -1. So all you have to do is second sine 9 divided by 15. That is the extent of this trig to find out how many degrees that angle is. Ready? Here we go. Boom. I just did trig. Second sine 9 divided by 15. Enter. And I just found that angle. Okay, and again, we'll have more. So make sure you get that down for notes. Let's look at our second situation. Come back up. Situation number 2. Let's say we have an unknown opposite. Given our angle, as we've already found, was 36.9. And let's just say we don't know what our opposite is. Same exact steps. Identify your pieces. I'm going to use sine. There's our formula. And again, I had put these down into your notes. And I'm going to plug my pieces in. Sine of my angle is 36.9 degrees, equals opposite divided by hypotenuse. That is my initial formula. Given that this is a proportion, in order to find x, I had to do the opposite of dividing by 15, which is to multiply both sides by 15. if you notice these stars exist, basically that means once you get familiar, you can skip this whole step up here, and this is what you're going to enter into your calculator and hit enter. So if you go to your calculator, just so we can see, sine 36.9, enter, and you'll see I basically come to 0.6. So I'm going to do that times 15, because I multiplied. The opposite of division is multiplication. And I get 9, which we know from our previous example was the number we're looking for, and is correct. So all I initially had to do, given this information and knowing my setup, is 15 times sine 36.9 and enter. And I just did the trig necessary to find that missing length. Okay, so let's look at our third situation of an unknown hypotenuse. So again, we have our angle, we have our opposite, and let's just say we don't know our hypotenuse. So I plug those pieces in. We know our sine formula, and so I'm going to substitute those in to my formula and get this equation here. Using proportions, I would multiply both sides by x. These would cancel. I'd have my x over here. And then in order to get x by itself, I have to divide, both sides by sine, and to get x by itself. Shortcut, switch these, literally. Make it easy, switch these two values, x goes here, sine 36.9 goes down here, boom, you have it. Go to our calculator, and this is all it comes down to. Once I know set it up from here, switch them and go, okay, I'm going to take 9 and I'm going to divide it by sine 36.9. Enter. And basically rounded, x equals 15. Okay? So those are the three different situations that you'll get of sine. So I'll zoom out so you can see it in its entirety of this page of notes. Again, feel free to pause whenever needed, but we are going to move on to some practice problems. So we have our three situations. We have unknown angle, unknown opposite, unknown hypotenuse. So feel free to copy these down. You can try them on your own, and I am going to work through them also to help you guys out. So feel free to pause the video, use your notes. Situation 1, identify your pieces, and then technically you can just skip down here to this formula, use your calculator, and get your angle. Situation 2, plug in your values, you know your formula, and technically You could skip down to this one here and just say, okay, I have to multiply by what would be in the denominator. In situation 3, identify your pieces. And if you notice, here is your star. You're going to take your opposite and divide it by the sine of your degree. So let's look at these. Again, if you haven't finished, please pause the video. So situation 1. My degree is, well, it's still theta, it's my unknown. My opposite is 24. My hypotenuse is 40. So my formula, sine is opposite over hypotenuse. Go to my calculator. Second, sine 24 divided by 40. I have my angle. If you want to, you can do even 8.6 if you want, even to keep it more accurate, or excuse me, 8.7 rounded. Okay, now I got my angle. Let's move on to the next one. Situation 2. Given that my theta is 36.87, my opposite is x, my hypotenuse is 40. So opposite over hypotenuse. So I'm going to take this to get x by itself. The opposite of dividing is multiplying. So I'm going to have 40 times the sine of 36.87. Using my notes. Here's my shorthand. Go to my calculator. 40 times sine 36.87. And if you notice, my answer is 24, which is exactly what we want to check our work. Okay. Last but not least on these ones, theta equals 36.87. Opposite 24. Hypotenuse is x. That is my ratio right there. X is in the denominator, so I'd multiply both sides by x and then divide both sides by sine, basically switching them. So 24 over sine 36.87. All I'm doing is switching them. Go to my calculator. (24) divided by sine 36.87 and 39.99999, or technically 40. So I know I went through them a little quickly. Feel free to replay the video as needed. Go ahead and use this up here to help you down here. And please note though, the only thing that's going to change is what is going to be referred to as the opposite now. That's the only thing that changes. The rest of these are going to be the same basic steps and same basic formula. So feel free to pause the video and I will post the answers momentarily. Remember, this is your chance to try it, test it, and start practicing learning how to do it on your own. To our last 3 problems of our 6 guided practices. You'll see my work. I used our formulas, used my cheat formulas, and again, this is simply a multiplication problem. 30 times this value. This was a division problem. That's all it was, 24 divided by the sine of that value. And, well, this was mostly just a plug in and hit enter. Second sine, 24 divided by 30, enter. That was the extent of this, what this one is here. So if you can visualize that this is going to be what most of all of foundational trig consists of for both sine, cosine, and tangent, then I hope you'll be able to see, like, okay, these 3 basic processes are going to repeat themselves over and over again in basically every type of sine problem that you'll get. I hope this helped. If you have any questions, let me know. Again, pause and replay any part that you need, and I hope you have a great day.